Okay, for a slope field, slope fields deal with differentials, just like we scored our homework and you were finding the original. Okay, this is a graphical representation of that algebraic equation. Okay, so you will be given a derivative, something like this. And this is the first, no, it's not. Let's do x plus y. Okay, this is the first one on your packet. You got a grid on there, right? You can just put that on the top left. Okay. So this goes back to what does a derivative mean? If you calculate a derivative at a point, what have you calculated? Yeah, slope, right? So this is just going to give us a bunch of slopes. Okay. So graphically, we're just drawing a bunch of little lines that represent the slope at that certain spot. Okay. So at the point 0, 0, the slope is 0 plus 0, right? Okay. You okay with that? All right. This might be too big. All right, so all you're going to do at 0, 0, whoops, wrong button. At this point, 0, 0, draw a little tick mark with slope 0. Yep, that's it. This is just a little slope of 0, right? Because it's flat. And we're just going to continue that process with the rest of the points on our grid. Okay, so what if we have the point 0, 1? The slope is 1, right? 0 plus 1. So at 0, 1, I'm going to scale mine. You put a little tick mark that has a slope of 1.
What do you mean you're going to scale it?
This is a half, so this would be 1, 2, 3.
Oh. You don't.
I'm going to go by 2s, that's what I mean. Okay, what about 0, 2? The slope is 2, right? Now, can you draw a slope of 2 perfectly? No. Just make it steeper than that. Like.
Oh yeah, that's a good point.
Okay. It is a good point. One of my favorites, 0, 2. Hunter.
Shouldn't that be on a diagonal? Because 0, 2 would be 0 up to.
Okay, sorry. I'm having a great day. But we could also do 2, 0, or 2, 0 and 1, 0, right?
Yeah.
Same deal. Look, fortunately, in our case, they're the same. So, yeah, I was goofing that up. What about 1, 1?
2.
Slope is 2. Are you noticing a pattern here?
Yeah.
What is it?
They're all going in line.
The diagonals are the same. See that? So one of the things you'll see here is a lot of times these will form patterns of some kind. Okay? Yes, they are line segments. So what about -1, -1?
-2.
Right, so
No, you went by 2s.
it's a wonder you guys learn any calculus at all. No, yeah, -1. I had it in the right spot.
Yeah.
Come on, man.
Bamboo. Oh, oops.
Jerk.
Got him.
What about 1, -1, or -1, 1?
0.
0. Okay, see the diagonal? Diagonal. It's going to keep going, right? These are all going to be 1, 0. I mean, just fill in the grid that you're given. On any test I give you, it'll only be like 5 or 6 dots. You're not going to have to do 15 calculations. Okay.
Yeah, so was I for a second.
I feel like we're drawing. Really gives me headaches.
I don't want to look at the other side.
Yeah, right.
Okay, so you've just drawn a slope field. Okay.
What is it?
Because he's as good as this, and here's just learning it.
Yeah, you'll get some practice.
I can't match you on the paper though.
What's the name?
What's the problem, Tyra?
Like, putting it in different quadrants, like I feel like I'm putting it, I feel like I'm trying to get down wrong, I don't know. Like,
No,
the
you're
action plan.
good. Oh, so, what is this telling me?
There's a slope. I don't notice.
It's linear.
So think about the original equation.
You're giving a linear.
It has a graph, right? If I solve this differential, I have a plus c on it, correct?
Yes.
So we don't know what the y-intercept is. That's what the plus c is, right? But what this is telling you is the general shape of the graph. So you have the shape of the graph, but you do not have the location. So this graph is going to look like this and look like this. It's going to have probably a slanted asymptote here. Okay, so the graph would look maybe something like this. Okay, but do I know where to place the graph? No, it could be here, it could be down here, it could be down here. The point is that it follows the same shape. Okay. So this is a graphical representation of the original function. These are all the little slopes at these points. Okay. What I'm concerned with is, can you generate a slope field? Okay.
Somewhat, yeah.
On a multiple choice question, could you match a slope field to a differential?
No, because I can't match this one.
Okay. What's the problem?
Oh, never mind.
Okay. So if you turn the page,
Oh my.
This is making it
Oh.
I'm gonna
you have 10 options of slope fields, and you have 10 differentials. Right? Can you match a slope field to a differential?
I think I can.
Is this one D?
Don't look at me.
Ah. Hunter, you don't say things like that.
G makes me think like
There are some strategies you can use.
Please enlighten us.
Go like this.
We just did
Oh, so it makes
x plus y, correct?
Yeah.
Okay, so
B.
you can generate a slope field. Does it look like this?
Yes.
Are there any other candidates? None of the others look like the one we just drew on the board, right? No, so that's probably number 7, is B. Right? Pay attention on these grids though, that 1 and 2, there are several slope field lines between those, so it's scaled by quarters with the tick marks. Okay, now take a look at this slope field right here. What shape is that?
Wait, that's a sine or cosine?
Sine or cosine, right?
Yeah.
So which one would it possibly be up here?
6.
Probably, or 9.
Wait,
Be careful there, because you have to generate that slope field to match the right one, okay? So be careful on sine, cosine, because it could be either. Just check it. Okay, here's the other one, I.
What is J?
Sine.
J is actually
You want me to just let you start working?
A is 5.
Okay. Get to work and then I'll just help you as you need.
Huh?